In this video, we will discuss how to find the volume of a solid given a cross-section by Finn McBride, Will Hoffman, and Lindsey Eastwood. Finding the volume of any solid using cross-sections can be solved using 5 easy steps. 1. Draw a picture of the base in cross-section. 2. Determine the axis of perpendicularity, meaning if the graph is perpendicular to the x-axis or y-axis. 3. Determine the chord length. 4. Determine formula for the area of the cross-section. 5. Plug the formula for area of cross-section into the volume equation and calculate, which you can do using a calculator. This is the formula for finding the volume of any solid given a cross-section. Volume equals the integral from a to b, a of x, d of x. A to b are the bounds on which you are integrating. A of x represents the area of the cross-section using the chord length. This formula would be used if the problem is perpendicular to the x-axis. If the problem is perpendicular to the y-axis, you must change it in terms of y. Using the following example, we will show you how to find the volume of a solid using cross-sections. So, find the volume of the solid whose base is bounded by y equals the square root of x plus 1. The x and y axis and x equals 3. The cross-sections perpendicular to the x-axis are squares. First, we need to draw a picture of the base and draw a picture of the cross-section. Now we need to determine our axis of perpendicularity. Since the problem states the cross-sections are perpendicular to the x-axis, our function will remain as y equals square root of x plus 1. Now let's find the bounds. Because the function begins at the y-axis, our starting bound a is 0. The function ends at x equals 3, so our end bound is 3. Next we must determine the chord length, because the bottom bound is the x-axis. The chord length will remain as y equals square root of x plus 1. Then we must determine the formula of the area of the cross-section. Because our cross-section is a square, the area equals base times height, or side squared. So the area would be square root of x plus 1 squared. Remember, if the problem states that the cross-sections are perpendicular to the y-axis, you must integrate in terms of y, meaning put the equation into x equals form, and adjust the bound accordingly. Lastly, plug the area into the volume formula. You may want to simplify to make it easier to put into the calculator. Using fn_int on your calculator, plug in this formula and calculate. The volume of this solid with a square cross-section is 7.5 units squared.
Thank you for watching this video by Finn McBride, Will Hoffman, and Lindsey Eastwood.